Hello everybody, this is Vinayak and welcome back to Voxfor Lifetime, your go-to source for Linux tutorials, security and server management tips, brought to you by Voxfor.com, your trusted provider for lifetime VPS, dedicated servers, managed WordPress hosting, monthly VPS plans and lifetime web hosting based on cPanel. In today's video, we will walk you through how to create self-signed SSL certificates for securing your applications and web server. A self-signed SSL certificate, which is a secure socket layer certificate, is when you create and sign yourself instead of getting it from a trusted certificate authority. While it's not ideal for public websites, it's useful for internal applications, testing environments, and private servers. Inside of a SSL certificate, we have several components such as PKI, which is also known as Public Key Infrastructure. It is used to manage certificates and cryptographic keys. It governs roles, policies, and procedures that ensure a reliable trust chain. There are several cryptographic algorithms such as RSA, ECC, or ECDSA. RSA keys are present in 2048 bits or 4096 bit sizes, while ECC, which is called ecliptic curve digital signature algorithm, is for more minor or faster keys. Next, we have the certificate authorities. For example, Let's Encrypt, which is a well-known authority which provides free SSL certificates. Next, we have Global Sign and DigiCert, etc. These certificate authorities ensure that the certificate is only issued to legitimate owner of the domain by performing various checks such as domain validation or the TNS record validation. There are two types of certificates which are used very largely in the web servers or website hosting space. The first type is domain validation type. It covers only your single domain name. However, if you purchase a EV certificate, which is called extended validation certificate, it will provide rigorous checks on the legal entity or organization which is requesting the certificate. Also, we have other certificates such as OV, which is called the Organizational Validation Certificate, etc. All of these SSL certificate authorities rely on a chain of trust command method. In this, the root certificate contains one or more intermediary and ends with the end entity certificate. Before we proceed further, I would like to tell you the requirements for creating a SSL certificate. Firstly, we need either OpenSSL or equivalent tools for generating keys, creating the certificate, signing request, and managing the certificates. Linux and macOS option Linux and macOS include OpenSSL by default, or we can install OpenSSL package by built-in PowerShell commands for Windows. Next, we need administrative privileges or root privileges for installing certificates in the system or root level. Next, we also need basic SSL or TLS knowledge, such as the knowledge of TLS versions, etc. Moving ahead, let's look at how to generate a private key for our SSL certificate. To do this, we will use algorithms such as RSA, ECC, or ECDSA. I will go to my terminal by copying the command OpenSSL space gen RSA to generate a RSA based private key using OpenSSL software on my Linux distribution. I will copy it, go to terminal, paste it, and press enter. This command will generate a key in RSA format. I will move forward and type cat space my domain key and press enter. This is the private key which we have just seen right now for our SSL certificate. Also, you should make a note that these files should only be accessible by trusted users or root users, and they can only read the keys. You should also maintain backups in a secure environment in case of accidental loss, such as getting a backup over FTP using rsync or other various methods which are available in the market. Also, you should never share your private key because it is only to be held with you on the server side. We will now generate a certificate signing request for our SSL certificate to be generated. Since we have learned about the private keys, I would like to tell you the private keys are only stored on our server, while the public key is distributed all over the world so that anyone can come and show us the public key. If the public key matches our private key, the connection will be established in a SSL mode to generate a CSR, which is traditionally sent to a CA called Certificate Authority to request a certificate. We will proceed further and type OpenSSL space REQ to request a new certificate. Space, we will specify our private key, and our certificate request will be specified using the hyphen out syntax. I will copy it, go to terminal, paste it and press enter. Since this is not a certificate which is being created by a well-known authority such as Let's Encrypt, DigiCert, etc., we need to validate the domain by providing these informations, such as if I'm living in India and I want to generate a self-signed certificate for my organization, I will type IN. Next, as the state, I will continue and type my state over here. Similarly, it will ask me for the city. I will type the name of my city. Now, it is asking for the organization name. If you are using this self-signed certificate for a personal use, you don't need to enter it. Instead, you can use the dot command and press enter. Organization unit, since we are not an organization, we don't have to specify it. In the common name, we have to type our domain name or the host name. I will type vinayak.voxfor.com. Now I will proceed further and specify an email address such as vinayaktest@gmail.com. Similarly, we will continue and specify a challenge password. Now we will enter a company name which is optional, so I will skip it. Our certificate has been generated and downloaded on our web server. To check for it, proceed further and type ls. We can see mydomain.csr file is now present. If we want to add multiple subdomains or hostname in the single certificate, we will use the subject alternative names, also called SAN. This can be done via a custom OpenSSL configuration file using the configurations present in our blog. You can proceed and check them out. Since we have a CSR file and the private key, we will move forward and sign the SSL certificate. I will proceed further and copy the snippet present in our blog, move on to terminal, paste it. This command will create a certificate with a validity of 365 days and store the certificate in mydomain.crt format file. I will press enter. Signature request is okay. It means we now have a SSL certificate present on our server. Since we now have a SSL certificate in our server, we will proceed and install it by a web server. To do this, we are using Apache based web server. Go to terminal and install it by typing sudo apt update, because sometimes we don't have the updated repositories on our server. Once the update is finished, we will move further and install Apache web server by typing the following command in our terminal. Move ahead and type sudo apt install apache 2 and press enter. This command will install Apache web server on our Linux VPS. Once it is done, we will proceed further and install the modules. I will copy this snippet, go to the terminal. Now I will paste it and press enter. This command will install the module SSL, and now we will restart the Apache server. To check if Apache is working properly, proceed and type sudo service apache status. Apache is active and running. Now we will move forward and configure our virtual host. To configure the virtual host, I will copy this snippet and move to the configuration directory that is present in /etc/apache. To go to terminal, type nano space our directory and press enter. In our virtual host configuration, we will proceed further and modify the lines by using this snippet. We will specify the SSL key for domain name along with its certificate file and certificate key file. In the terminal, proceed further by copying the snippet and going to terminal. Now we will adjust the virtual host configuration or add a new one inside of this file at the bottom. To do this, I can see that the virtual host configuration is ending over here. Now I will enter in a new line, and the domain name which I want to specify is vinayak.voxfor.com. So I will type over here vinayak.voxfor.com. Now, instead of path 2, I will proceed further and type /root// my domain.set. Same goes for the key file. So I will change the path. Now we will exit our virtual host configuration by pressing Ctrl X, Y and enter. Since we have now exited our Apache configuration, proceed further and enable the SSL side and then restart Apache by typing A2E inside default SSL. I will copy it, go to terminal, paste it and press enter. If you see permission denied error, make sure your server has the right to read certificate and key. For example, you can run the command chmod space 600 to your domain key to restrict access in Linux. Similarly, if you face a invalid key format error, ensure you generated a RSA or ECC key suitable for your server. If you see errors about an unsupported key, regenerate with proper parameters. Similarly, if you encounter a mismatched certificate and key error, make sure you use the same key to create both the CSR and the final certificate. Similarly, if you see browser warning that it is a self-signed certificate or the certificate is invalid, you can remove them using the import certificate option present in various browsers. Similarly, if you face an error that certificate is expired, you need to create a new CSR and self-signed certificate with updated expiration dates. There are some security best policies as well, such as limiting the scope of your self-signed certificates for local or internal testing only instead of deploying the self-signed certificates to a production server. Also, you should use strong keys with RSA of 2048 bits or ECC based key for a strong encryption. You should also keep the lifespan of your SSL certificate to a minimum of 90 days and change it every 90 days using cron jobs, etc. We have already covered the creation of SSL using certbot on our YouTube channel. You can move ahead and check it out. Similarly, you can proceed further and use secure key management by storing your keys in a secure location with only read privileges and maintaining separate backups. Also, even if you are having some local projects, establish a private certificate authority for more efficient and smoother trust management across the organization. As we discussed previously, if you encounter browser warnings, you can address them by adding an exception for local or development purposes in your browser. You can also import the SSL certificate which you have signed as a trusted authority in each browser or device you will be using, or the device which will be used to access the projects. Similarly, you can register as a private CA called Certificate Authority for creating your own CA and importing its root certificate on your system. By doing this, the browsers can trust the certificate you issue under that particular certificate authority. If you want to renew your SSL, I would recommend you to copy the snippet which is present in our blog. This script will help you in regenerating or renewal of your self-signed certificate. Similarly, if you want to revoke a self-signed certificate, you can remove the certificate from servers to prevent further use, or you can delete it from the trust source. That's it for today's guide on creating self-signed SSL certificates. We covered OpenSSL installation, certificate generation, configuring web servers. If you found this video helpful, subscribe and share it with others in the DevOps and security community. For more tutorials, check out our blog linked in the description. And remember, whether you need lifetime VPS, dedicated servers, managed WordPress hosting, monthly VPS plans, or lifetime web hosting based on cPanel, Voxfor has you covered. Thanks for watching and see you in the next video.